Okay, we're in exercise set 90 now, and we're going to start with certainly problem number one. I do want to point out what you're starting with over here is you're starting with something here, and your goal is to get to the nth term of that, all right? We'll talk about that. I'm not a stickler on starting anywhere, but I'm pretty sure that Wells is a stickler on always starting with n equals 1 and moving forward. I will say for convenience though, sometimes it doesn't really pay to start at 1. You could start at 0, 2, any integer you want, by the way. But anyway, I'm going to try to aim for n equals 1 as a starting position. Initially, I may not get there, but I will get there eventually, all right? So what I want to do is say I really don't have enough room to put the work down over here, so I want to go to the whiteboard. And let me do that. And in the whiteboard, I'm going to start with that, writing the problem down. And what's the problem? Well, you got to have your sheet out, and I'll write the problem down for you. It's 3 over 1 minus x minus 2x squared. Your first goal is to break it into two fractions, hopefully with linear factors initially. So I'm going to say I don't know. We've done this before, many times before. I don't know. And the linear factors, kind of looking at it, I'm going to say 1 plus x and then 1 minus 2x. Now, before I go forward, I want to make sure this is correct. Just multiplying it out, what do you get? You'd get 1 minus 2x plus x is minus x, and you do get minus 2x squared. My goal is to get the a and the b now. So how do I do that? Multiply both sides by the LCD. You're going to get a times 1 minus 2x plus b, 1 plus x. Then I pick an easy number for x, like minus 1, and you can get 3 equals a times, let me make sure I did that right. I chose minus 1, so that's 3a, right? And then what do you get there? A would be 1. All right, let me get my eraser out, and I'll put that down now. Okay, what are you going to do now? Pick another number, an easy number. I'm going to pick 0, but again, you're free to choose. You get 3. Let's say if x is 1, I get 1 plus b. So what does this mean? B is 2. Let me get my eraser out and erase the b now. And the b is a number 2. So, if you think you're done here, not really. You're not done. What you're looking to do is you're looking to see this pattern. And if you see that, it's fairly easy to write down if you do see the pattern. And this is going to be true when the u is between minus 1 and 1. All right? So it's geometric pattern, and I'm looking at it, and the first thing I notice, I want to put 1 down at a time, and I think I can do it. So it looks like 1 over 1 plus x. Well, that's certainly in that pattern, but it does look a little different, so I want to get it exactly like that. So it's going to be 1 over 1 minus x. So now the u is just simply minus x. So you would get 1 minus u plus u squared minus, whoops, I'm sorry, I'm putting u down. I made a mistake there. I got to erase that. I got x there. Sorry about that. So it's going to be 1 minus x plus x squared minus x cubed plus x4, and then you put minus yada, yada, yada. The pattern's pretty simple, by the way. Let me put the next one down. The next one's a little more difficult. It's actually 2 over 1 minus 2x. So this is going to be 2 times 1 over 1 minus, in parentheses, 2x. Well, let me write that down. It's going to be 2 times something now. Well, I'm using that geometric pattern. What's going to be 1 plus 2x plus 2 squared x squared, excuse me, 2 cubed x cubed plus yada, yada, yada. All right? I'm going to simplify a tiny little bit. And the reason I didn't notice the 2's all over the place. So I'll say 2 plus 2 squared x plus 2 cubed x squared That's a square over there. And I definitely see a pattern here as well. 2, 4, x cubed. Whoops, I did it again. Plus yada, yada, yada. All right? What am I going to do now? I'm going to add them together. So it's going to be 1 over 1 plus x plus 2 over 1 minus 2x. Now, certainly when I add these things together, I want to point out I'm kind of doing it by term. All right? Term by term. And I'll write that down, hoping to see a pattern. So I'm going to write down, and let me just take a look at that. It doesn't matter the direction I write it down, but I think I'm going to write down 2 first. And that's plus 1. And then you'd have no x's. All right? The next term, it's going to be 2 squared minus 1, and then there'd be 1x. All right? Let me just put out what I did over here. I did this, and I did this. All right? I'm going to go to the next term. And the hope is to see a pattern. Plus. Well, then you're going to get 2 cubed. Let's see, plus 1 x squared. Then you're going to see 2, 4 minus 1 x cubed. And then I'm going to say yada, yada, yada. All right? I'm going to write the sum down first. Before I do that, though, I want to point out there's something peculiar about this. And I want to just focus on one thing at a time. X cubed, x squared, 1x, and then no x's. All right? So I'm going to write this down, but I'm going to start putting powers on the 2. 1, 2, 3, blah, blah, blah. Let's put this over here. I'm going to write the sum down. I'm going to start at 0. You know what? Let's start at 1. Let's put this down. Start at 1, and I'm going to go up to infinity. I got to be careful now. And I'm writing down what each term looks like. Well, if I'm starting at n equals 1, I want that first power to be 0, so this has to be n minus 1. And the 2's got a power, right? So it's going to be 2 to the n. So I covered the x, I got the 2 covered. Again, if you look at the 2, right? So 2, 1, 2, 2, 2, 3, 2, 4. x0, x1, x2, x3. That pattern's pretty simple. The other one's alternating, all right? And I notice it's always going to be a 1 there, but it alternates. So I'm going to write this over here. So I'm going to put the plus minus 1 to some power. It looks like either it's going to be n plus 1 or n minus 1. And you're entirely free to choose, all right? I'm going to say, just to be consistent, I'm going to say n minus 1. All right? So let's see if that works. Certainly the x and the 2 works. Let's see if that minus 1 to the n minus 1 works. If you got 1, you get minus 1 to the 0, which is 1. If you put a 2 down, what do you get? Minus 1 to the 1, which is minus 1. Works beautifully. All right, so if I were starting at 1, let me write this down for you. an equals 2 to the n plus minus 1 to the n minus 1 times x to the n minus 1. All right? So, and this is where n equals, where n starts at 1. I shouldn't say it equals 1. Let me reset. N starts at 1. So n is 1, 2, 3, 4, yada, yada, yada. Starts at 1. So I'm going to put a box in this. And I want to go to the key. Now, certainly you're going to be confused when looking at the key and say, how'd they get that? Well, let me look what they did in the key. I'm looking at the answer. And I want to point out what I'm seeing in the answer. I'm definitely seeing 2 to the n. I'm definitely seeing this over. Whoops, sorry about that. I didn't mean to do that. I thought it may highlight around. I'm definitely seeing this, and I'm definitely seeing that. All right? But I see something different there. And I want to tell you how they got that. So what they did, let me write this down for you. What they did, they took this minus 1 to the n minus 1 and wrote it as minus 1 to the minus 1 times minus 1 to the n. Well, what's minus 1 to the minus 1? It's just minus 1. So you get minus a minus 1 to the nth power. So you could have also written this way. 2 to the n minus 1 to the nth power times x to the n minus 1. That often confuses students in the beginning when they see a key and they say, I don't know how they got that answer. They're looking at their answer, which may be correct, by the way, and then they look at the answer in the key and they say, oh, it couldn't be right. Here's the deal, though. They're identical answers. Which one looks better? That may be a matter of opinion. To me, they look the same. All right, they really look the same. Your mileage may vary. Again, I want to emphasize, you decide what looks best. Hopefully your teachers, when they're grading these things, they're not confused by what you have written down. Some people demand them written a certain way. Other people are more flexible. By the way, starting n equals 1 is not essential. You could have also started this at 0, but your answer would look different. It's a good idea, though, to write down what you're starting with. Again, Wells is assuming you're starting with 1, but the point is you could start at another number. All right? Thank you.